Lesson 2.8 is on two variable inequalities, and the objective is to be able to graph them. Alright, there's three steps for graphing a two variable inequality. The first step, we want to graph the boundary line. We're going to use a dashed line if the inequality symbol is less than or greater than, and we're going to use a solid line if the inequality symbol is less than or equal to or greater than or equal to. The second step is to pick a test point not on the boundary and substitute into the inequality. Usually this is going to be 0, 0. That's going to be your easiest test point. And then finally the third step is to shade the correct half plane. Alright, so problem 1. What is the graph of the inequality y greater than 3x minus 1? So the big thing here is to solve for y, which this already is. This is already, the y is already isolated. Once that's done, in order to graph, go ahead and treat this inequality sign like an equal sign. So treat it like y equals 3x minus 1. We can graph this line because we know the slope and we know the y-intercept. Right, the y-intercept is -1, and the slope, which is our rise over our run, is equal to 3, or 3 over 1. So, what's the first thing you do to graph the line? Plot the y-intercept, -1, and then use your slope to find the second point. So, I'm going to go up 3 over 1 from my y-intercept. And then down 3 to the left one. Alright, now once we've done that, we're going to look back to our inequality here, where it was already solved for y, and see that this is a greater than sign. Because it's greater than, we're going to use a dashed line to connect our points. So step 1 is complete. We've graphed our boundary line. Step 2 is to then pick a test point. Usually it's going to be 0, 0. Alright? So we're picking a test point not on the boundary line. 0, 0 is not on the boundary line. And we're going to plug that into our inequality. So we're going to plug 0 in for y, and we're going to plug in 0 for x. So we have 0 greater than -1. And you ask yourself, is 0 greater than -1? And the answer is yes. So you're going to shade the half plane toward the test point, and this is step 3. And you're finished. Let's do another one. So here we have y less than or equal to 3x minus 1. Alright, again, our y is isolated. So we then treat the inequality sign like an equal sign in order to graph it. Our slope is equal to our rise over our run, and just like the previous problem, it's 3, and the y-intercept is -1. So plot the y-intercept and then use the slope to find the second point, so up 3 over 1, and then we can go down 3 to the left one. Now, unlike the previous problem, our inequality symbol is less than or equal to. So therefore we're going to use a solid line to connect the points. So we've graphed the boundary line. Step 1 is finished. Step 2 is to then pick a test point. 0, 0. Alright, I'm going to look at my inequality and plug in. Alright, so is 0 less than or equal to -1? And the answer is no. So we're going to shade the half plane away from the test point, or the half plane that does not include the test point, which is this. Okay. We're going to skip problem 2, and we're going to go to the last one, number 3. Alright, here we have an absolute value inequality, and what you'll notice is that y has not been isolated. It's not been solved for, so we need to do that. So we're going to subtract 1 from both sides. So we have -y less than